All right, welcome everybody. Thanks for coming back. We're in week 2. We are going to be talking generally about algorithms and data structures this week. We're going to wrap up a few things with Python syntax that we need to make sure that we have in our tool belt before we start doing our algorithmic problem solving, which is where we're going to end up today. Some tools and things that are in the free coding resources that are good practice sets and good things to use in that regard after we get through the syntax points. So that's about all we have for slides. No real theory. We're going to be more hands-on today. And the review, again, Anthony's question before we started recording, before the class started, was really on point. So let's go over into Python Anywhere. Let's kind of catch up quickly on where we are and see if anybody still has any outstanding questions, and then we can press on from there. So over in Python Anywhere, if you want to follow along, definitely suggest it. We can go. We're gonna need one bash console. Just keep that running. Then we're gonna keep open. Just going to open it from here. And then if you recall, this was the question that Anthony had. So we're in our kind of home directory here. If I list what's here, just ls, we have our readme.txt that comes default, and then we have our main.py. And I can just use cat to like read what's in here. So this just printed out on the screen what's in our main.py. So we have the definition of our main function that's going to return this string hello world. And this is the piece that Anthony was asking about that was still somewhat unclear. Right? So everybody tracking on this part so far. Let's open up that actual file in our GUI because we're gonna do some more messing around with it today. But I'm gonna keep my console open because we're gonna run the commands through the console. All right, so in the file, the directory, I'm going to open this up so that it's inside of our text editor. So it's going to open in my main.py file and look at that same thing that was in there. So we have our definition. And this is, Anthony, what you're asking about, right? So when we go through our different control structures, our first one that we talked about is a sequential control structure. And that's the default where the computer is just reading the file that you tell it to read in whatever directory you tell it to be in. That's this Python command, right? So we say Python 3 is the interpreter that we want to use. We do Python 3, and then we give it some sort of file, right? So this file is right here, and it's going to read from this line as fast as it can, get this definition, and then it gets here, it's going to evaluate this statement and see if it's true or not, right? So Anthony, this is where your question was, right? May not be able to come off mute, but that's right. So this right here, as a quick explanation again, is when we call this, we make this statement, we say Python 3, and we call our file, it's going to read through, and it's going to be passing this information, and this is basically saying, is this file the file that was called directly? That's what this is really doing. And so when we say that this file was called directly, it is like the root file of your application, and it's the main file. And so it'll run whatever you tell it to here.
So why are there underscores? Wouldn't that change the name? Because the name itself doesn't have underscores.
Right. So this isn't a name that you're seeing overtly. This is something that's like written in here as the main application that's being run. And this might make a little more sense when we go through setting up a second file and linking them together and calling it through one file, because that's what it's letting us do. So these double underscores are showing it's a reserved variable name. It's not exposed anywhere, right? So it doesn't have anything to do with this main.py right here. We could call this file anything we wanted to. We could call this,
okay,
you come up with any name you like and call it that, and it'll run just fine. The main that this is referring to is really just saying that the Python interpreter, this thing right here that we called it, is calling this file directly. That's kind of the main thing that I want everybody to grab from this. We don't need to know exactly how this works under the hood. There's a lot more to learn for it, and I understand that may seem somewhat slippery, but I want to hammer really the concept of files in directories, right? We have this main.py file in this directory. Here's our /home/username/main.py. And we can access this file, and it will run an application, and that's what programming is. And this right here is a piece of that entry point for the interpreter to know how to treat these files in these directories. Is that helpful at all, Anthony? Or am I confusing the explanation?
I I say I'm with the 3. I'm kind of missing here, and I'm going to have to watch the video again.
Okay. Okay. And again, as we go through and build, we're going to build classes today in a separate file, and we'll link them together, and that might help make it a little clearer. And if it's still not quite clear on how this is working and why we use this app entry point, I could find a pretty good article and share it with everybody that'll help explain what this
I
construction means and what it's doing.
I understand it's the main linker, what we call main, and then from there it just like the root of the application, and then it goes into the print is starting to execute the code line by line.
Mhm.
I just only confused about how can main.py equal underscore underscore main underscore underscore.
Right. Yeah. Yeah. So like that's the thing you got to
That's the only thing.
Yeah. Yeah.
That's the
So
only thing I'm confused about.
So decouple those in your mind. Like this file being called main.py has nothing to do with this main right here. They're two totally separate things. So just
Oh,
if that's the simplest way to get to it for now, just they have nothing to do with each other. This main.py
okay.
right here could be called literally anything, and it would
So
still run
any
as main.
file.
Yeah,
Oh,
and
I
this
see.
would still be main the way it is because
Oh, got it.
this main is referring to the main file in the directory. That's what it's saying basically.
Oh,
Good clarification.
Yeah.
Question kind of following up on that.
Sure.
In def main or define main, could that be anything there? Or is
This
there like
main.
main, secondaries, tertiaries?
No, absolutely. This could be anything. Again, we could call it hello. As long as we call it the same way in here, it should still run exactly the same way in here.
Okay.
And it does. So this again, that's sort of by convention that you'll see that there will be a main a main function in your main file, and it just happens to be redundant naming. And that happens a lot with things where it's like unclear why these things have the same name over and over again when they're actually not related to each other. So sometimes it's convention. So again, I'm glad you asked. It's very good to understand why the word main is used 3 different times and is absolutely not associated with each other. And some of them you can change and some of them you can't, right?
So when you changed def main to def hello, do we have to change the word main in the logic?
This
function?
Right here?
Yeah.
No.
To hello. So that will always remain.
Yeah. This construction is like a standard construction that it's adjusting things that we don't have direct access to that are being called here in this part of the command, the Python 3 part. So again, we have to somewhat decouple those things, right? So that this is always going to be main with 2 underscores, and it doesn't reference any function we put up here, even if we do use main or the file name. Even again, if we use main, those things can change, and it won't affect this at all.
This might be jumping ahead a bit, but if you're building like a more complex code, would it be is there things to call after main, like is main just primary and then there's other aspects you can call, or is that just it?
Yeah, that's a good question. No, I don't think there really are, because this, and I'll show you why in a second, because when we start linking together files and stuff like that, you really just need one of these. And you don't end up having, you do that thing that you're talking about kind of somewhere else, basically, and import it in other ways. That's a good question.
So I'm in the bash console and I typed in Python 3. Now I got the 3 right carrots.
Oh yeah.
How do I go back to the tilde?
Oh yes, you do
/quit.
Yeah, quit.
Or not slash.
Yeah, not slash, but quit and then open and close parentheses.
There we go.
Yep. I'll get you back to your console. Cool.
If we were to
Go ahead.
see how you have like your bash console open, and you also have you have the main py file open also. Do we have to, can we do that, or do we have to have pay for the service?
No, yeah, you can do that. Just open these I just open these in different tabs.
Just open in
my browser. Yeah.
Oh.
This is all free functionality for sure.
I don't know why mine won't do it. So.
It won't?
Maybe it's just me.
Oh, interesting. Yeah, I just on this thing just right clicked and did open files in a new tab. And then so I have my bash console. I know you could just navigate back and forth if you needed to. But all right, so again, I understand that this is a slippery concept. I don't mind going over it a few times, but as we get through the parts we're going to do today, we're going to plug it in a little bit more, use some other files, and hopefully it'll make a little more sense on at least how this operates. But I understand the confusion, so definitely ask questions. And don't feel bad if it feels like it makes sense for 1 second and then it doesn't make sense the very next second. That's absolutely part of the trip. So just enjoy that piece too. All right. So the last few things that we got, unless, again, any other questions real quick before we move on? Okay, cool. So we're going to go through a couple more control structure things that we need to use as our basic set of tools for making more interesting algorithms and doing some more interesting stuff. And the first one is sort of a continuation of this if statement that we use down here. Now, we're not going to talk about this particular logical thing, but we're going to take this if logic to its completion so that we have a full set of it. When we do these next examples, we're going to do them in functions, just to get in the habit of writing functions. But again, these don't have to be done exactly like this. So we're going to define a new function, and we're going to say like compare two numbers is the idea. And so this is going to take in two inputs. These could be variable names. Or these are variable names. So you can give them basically whatever you want to. I'm going to do A and B, but you could do X and Y, or num1, num2, whatever you want to, but it has to follow the same variable rules as any other variable in Python. Can't start with a number, has to be a continuous word, no spaces, things like that. And then I'm going to use just some simple comparisons to build a simple logic to show the options of what a full if block of code would look like for several options that you might want to go through, right? So let's say the first one is if A is greater than B, right? So we do the same sort of thing that we did down here with the name, the main thing, where we write word if, and then our logical statement, and then a colon. And then we're going to move down into two blocks, or it's two indentations over, right? So 4 spaces or 2 tabs. Got to be consistent if you're writing in something other than this code editor. And then inside here, we're just going to do a return. That's just going to say a string, keep it consistent with the single quotation marks that say like A is larger. Cool. Now, if you want to do another condition, right? So we're going to say another condition of this is a combined word standing for else if, and it's ELIF, pronounced elif, right? So if you kind of read this like English almost, you say if A is greater than B, do this thing. That's what this colon means. Return A is larger. Else, otherwise, if, and then it's going to expect another statement, right? So we could just say A is less than B. We'll return that. We'll say B is larger. And then the last piece, you go on with those as much as you need to, as much as your logic requires. You could put another elif here if you had more conditions you wanted to check. The last one, if you want to be explicit about the last case, the sort of catch-all that doesn't meet any of the other criteria, is just else, just the word else, and then a colon. And that's not going to require a logical statement after it because, again, it's the catch-all. It did not meet any of the other things. This is the other one. So we could say, A and B are equal. All right. So this is just a simple example of how an if block might look, where you have one criteria at the top. And what this is going to do when it reads top to bottom, when we call this function, we're going to give it 2 numbers. And it'll go to this first part and read and say, okay, does this come out to true? If it comes out to true, it'll enter this code block. If not, it skips down to the next piece. And it'll check this condition. And it just does that all the way down until it reaches a true condition or it hits the else condition.
Could you use print instead of return?
You could. Yeah, we could just print these out if we wanted to just print these out directly. Or we could follow the same convention and just print out our compare nums down here in the bottom and then give it some numbers like 5 and 6. Let's see how this goes.
So for that, could you also do like an if and statement?
Oh, like adding, yeah, absolutely. So in your logical statement, you can use other things like and put another condition in there, like A is greater than 0 or whatever. You could do or as a reserved word. That's saved in there. You could just put that in there. And you
So
can,
could you use like an or statement instead of the elif?
no,
Just put it under one.
no. I mean, well, yeah, you could, I guess, if you want to say, well, yeah, if your logic makes sense for that, yes, you could. But that'll be based on whatever logic you're trying to use, right? So syntactically, yeah, you could. You're not required to use elif statements. If you could put it all into an or statement and just have one thing in there, you could do it that way too.
Can the compare underscore nums, is that arbitrary or is that a set command?
Nope, that's arbitrary. So this you could call it whatever you want to. You could just make it. You could just call it compare. You could call it whatever you like.
Define is making a function that we're making our own custom function, basically.
Yes.
So
Yes.
whatever we name it is whatever it is.
Yep. Exactly. All right. So then this should give us, if we did a couple of these, I guess we could do, to test all of our different things, we could do some numbers that are going to meet all three of our conditions all at once, because then it'll run all three when we call this main.py, and then we'll call it exactly the same way that we've always called it. We'll just do Python 3 main.py, and we expect it to run our number comparison 3 times. So the first time we have A and B is larger, which is true. We gave it 5 and 6, and so that worked. And I said A and B are equal as the third one, and that works because they're the same. But this may be, faulty logic, because if we pass it 2 things that don't fit these criteria because they don't match each other, it's still going to say they're equal when they're not, because we didn't actually check for equality. But this is just to be demonstrative of how you would build your logic. So there may be an error in that logic. You may have to run some more tests to figure out exactly how it's working. But these are the tools you need. You need an if, elif if you have other conditions you want to look at, and then finally an else statement, which again is not required. You can just have an if and then do this catch-all as, like here, we don't have anything else after the if statement. There's nothing. So basically the idea here is that if this doesn't work, if this isn't met, it just exits with nothing. There's no command run at all. You do the same thing in your own custom code, but these are all the pieces of an if block of logic. Any questions about this?
So I have a quick question. When I write in Juniper, like when I write another, we're able to cut and paste.
Yep.
Is that something you're okay with? Like, I would be okay with just cutting and pasting the elf is else. Is that okay?
No, I hate cutting and pasting. Yeah, absolutely. I'm not sure. Yeah, I'm not sure I'm following your question.
Like, I don't think it's a personal preference. It's more a matter, will it cause an error if I do it?
If you cut and paste? No, it shouldn't. If you paste into this document, no, you just have to make sure that you keep track of your spaces and you don't mix tabs and spaces. But this thing may clean it up automatically for you.
Okay.
Because that's the most relevant thing in Python is the spacing. But yeah. Sure. Any other questions?
Could you have one? So I know we changed the bottom of it to like return certain numbers. Could you have it to be where the file could both print hello world and do the number comparisons in one go?
Oh yeah, absolutely. We could call both of these functions down here if we wanted to. I didn't call them just because to save space, but we could absolutely call as many as we wanted to. And then another thing, just kind of as a call out. Oh, I didn't actually print this one though. Add that just to demonstrate that it will still work. So there's our hello world and there's the rest of it. So I was going to say, just kind of as a point here, a lot of times what you'll see when you look into a main file of some sort, whatever application you're looking at, whether it's called main or something else, it will have some main function up here, and then oftentimes it'll just have the main call down here, and all these sorts of things are up in that main function. You know what I mean? And it'll run kind of like that, and you'll see it more like this. I'm putting everything down in this part of it just to be really hammering the point that this is what's being run when we call it from the other place. But
if you put it before the thing is defined, though, how will it know what to do?
It won't. Very good call. So that's the other thing is if you do it this way, you have to be careful of what order you make these things in, because if you call this compare nums up here before you created it, when it does this sequential control structure and reads through, it's going to be like, I don't know what that is. So, all these things are decisions that need to be made. And they affect how things operate. But good question. Any other questions? Is that right? Yeah, that's right. Okay. All right, cool. All right, so the next two things that we're going to go through are operations that can be done on what are called iterables, which I think is a terrible sounding word, but it's anything that can be iterated through, anything that has several items that you could repeatedly go through something and do something with it. So what are the things that we've talked about so far that strike you as possibles for iterables? What data types have we mentioned so far that might be an iterable?
Lists.
Lists. What else? Lists are a good one. What about dictionaries? Think we go through dictionaries?
Yeah.
That's what I said, but I was muted.
Okay, yeah, nice. Yeah, yeah. So list, dictionaries, basically those four collections of things that we talked about: list, dictionaries, tuples, and sets. We're going to do mostly lists and dictionaries most of the time because, again, they're more frequently used for solving problems, especially the early stages. And depending on the issue, dictionaries. Again, there was a question asked in Discord about how to do a specific thing, and we can use some parts of the if statement that we just did to do that, coupled with probably a hash table. But let's go through these loops first. So the first one, again, these are called, iterative things are called loops, right? There's two different kinds of loops that we're going to use that are really good to start with, even though they may not be the best way to do things. You may want to learn faster ways to do this eventually. This is a great place to start, and they will solve problems. It's very, very handy. The first one is called a for loop. And what this is going to do is go through each item of something and do something with that item in it, right? So let's imagine we have a list of things, and we have a whole bunch of things that we want to, like, we want to pull each item out of that list and just look at it and just print it out on our screen so we know what's in the list. So let's do a function that'll do that for us, and this will show what a for loop will do. So we'll say df, like always, going to define our function. And we'll do show list items, and it'll take in something. I think list itself is a reserved word. I could check by typing it, and you see it changes color, so we're going to leave that alone. But ls is not, so I'm going to use that as a variable name to represent our list. So this is, again, a variable input name. We could basically call this whatever we want to, as long as it's not a reserved word, inside of a parentheses, and then a colon. So we have show list items as the name of our function, and inside of it, we're going to put our for loop. So it just starts with the word for, which is a reserved word, and then another variable. So a lot of times you may see people just use the letter I, for the item or something like that. I'm going to use the whole word item. Again, follows the same variable names. This is arbitrary. You can pick whatever you like. And then you say, so for variable name, for item in, which is a reserved word. And then we say our collection, whatever that thing is. In our case, it's the ls that's been passed in. All right, so this is our for loop statement. What this is going to do is for each item that's in that list, it's going to do whatever we tell it to do in this code block. So now we entered in again, there's a colon, so we moved down in, we're 2 indentations in, and we're going to tell it to do something. So this one, just because we're demonstrating, we're just going to print that item out to the screen. We're not going to do return statement this time, just going to print it directly because it's more about the for loop and how it works than anything else. So if we go down here and make an example, say my list, and set it to any number of things, let's do 9, a string. I don't know why I always just write the word string. Let's put an inner list in here with a couple of things in it because we can nest like that. And then we'll say show list items and pass as an argument our my list object or list, sorry, that we made. Since this has a print statement built into it up here, we decided to do it that way. This time we don't have to tell it to print it down here. When it calls it, it should print it directly. All right, so when we save this and we run it, what it's going to do when we make the call is it's going to come in and create this list for us, and then it should run and print each one of those items out because with this for loop. So let's try that real quick with our Python main.py. And there, as you see, it went through each item and just printed it straight out, including the internal list. It did not go into that list and loop through those items. If that's something you want it to do, you have to explicitly tell it to do that. You can nest these for loops. You could put another for loop inside of it, whatever the other thing is inside of that. Say item, if the things inside are iterable, if you have nested lists, so you can nest our for loops similarly, and then do what you need to do with that, right? So you could do that again. We have to come up with another variable name, and then you'll be presumably looping through this thing. So it can get really complicated with this, but this is the basic part that you need for a for loop. It's for variable name in, and then your iterable and the colon. Any question about for loop?
For this, since you're able to create and edit lists in the Bash console, would you be able to edit this list from the Bash console?
Good question. No, because it's only right here. So if you wanted to do that, yeah, you'd have to like do some import stuff and go through the Python console. But no, this isn't going to be accessible in any interactive way in the Bash console with how it's written. Any other questions? All right, so the next loop that I want to talk about, I don't know, I think it was maybe Anthony was talking about running this not in Python anymore, but on their own device. Big warning on this one. If you're doing that, you could absolutely crash your computer with this loop. This is something that can go on endlessly if you don't do it right and you don't put a stopping point into it. So that's going to be useful for us to do it in the browser, because if it goes over its limits, which we'll push it to like demonstrate, it's not going to break anything. It'll just kind of tell us that it's not going to do it anymore because it's taking up too much power.
I think I did that earlier.
Nice. So this loop is called a while loop.
Yep.
So similar to this, we're going to put it into a function. This time, let's imagine a scenario where we have a box of some sort, this imaginary box, and it has a certain number of things that it can hold, right? And so this container, this box, we're going to fill it up to that maximum amount of things. I'm going to show that this while loop basically checks the condition that we're going to give it. And as long as that condition is true, it will go through a block of code for us. So what we're going to do is check the contents of this box. If it's less than the maximum, we're going to add 1 to the box until the box is full. So we're going to make a function that does that, right? So we'll call it container filler as the name. Again, there's an arbitrary name. You can call it whatever you like. And we'll set it up to some sort of maximum. I didn't use the shorthand max because I'm, again, pretty sure that is a reserved word somewhere. So I'm going to leave that alone. It's really commonly used. So our container filler, we're going to give it a maximum. And then inside this function, what typically, again, you're going to need to do is put in something that's going to change, right? So unlike the for loop, we're not just going to dive into it. We're going to set a variable first. I like to use the word count just to keep track of how many times it's gone through this thing. It'll give us something that we can change and check, and we'll set that to 0. So we'll initialize a count variable at 0, and then we'll do our while loop, which is the word while, lowercase, and then we will check a condition. So we're going to say while the count that we just made and set to 0 is less than the maximum, we want it to enter this code block and do a thing. So it's going to check this logic. It's going to say, all right, cool. Yeah, the count is 0, and its imaginary maximum is 5. It's less than 5. 0 is less than 5, so it's going to enter this code block. So now that we're here, this is where it can break stuff. This is where if you don't set some sort of way for this to change from being true, once it enters this loop, it's just going to keep going because that condition is always true. So you have to really make sure that you change whatever your condition is. So as a habit, the first thing I'll do is I'll increase the count by 1 when it goes through 1 iteration. And the way you do that is an operation called an increment operation. So you use the plus sign and the equal sign together with no spaces between them. So you do count, plus, and then equals. So it's like setting this variable to 1 higher, or however many higher you want to. In our case, we're just going to go up by 1. But you could increment as many as you like based on whatever logic you need. But this is a real common way to go up by 1. So each time it gets to this line of code, we're going to increase the count by 1. And then we could just keep running this until it's maximum and be done with it, but let's give ourselves some sort of output that tells us what's going on at each step of this. And we're going to do another thing with strings. It's very handy, and then we're going to use it a couple of times. You're going to see it all over the place, called a formatted string. And the way we write those is just the lowercase letter f, and then our quotation marks. So I'm going to open and close it and start writing in between the quotation marks now as the string, and just give ourselves a message. So I'm going to say the container has, and this is why we're doing formatted strings, though, is because what we can do is we can now insert values from our variables in here using curly brackets. So if I put the word count in curly brackets, it's going to put whatever the current count is for this variable value inside of this string and print it out into our console for us. So each time it goes through this loop, it's going to check this condition to see if it's met. So the first time it comes through, the count's going to be 0. It'll be less than our maximum. Presumably, we'll give it a number bigger than 0. It'll increase the count by 1, and it should print out a thing that says the container now has whatever the current count is. And this right here, adding things into a string, is called interpolation, which is a fun word to say, but it really just means sticking things inside of other things. So we can interpolate our strings using a formatted string.
As opposed to extrapolation, which means adding things onto the end of things.
Yeah, very nice. Yeah, absolutely.
I thought that was appending.
Yeah, that's also true.
It's a synonym.
Yep.
I used my English degree today.
I love
It's
it.
paid for itself.
Yeah, yeah. All right, so then
What's the difference?
What's that?
Oh, what's the difference? What's the difference between print and return?
Good question. So print is a built-in function that just sends whatever you tell it to out to this, what's called a standard output, which in our case is our bash terminal. Return basically is just going to send this into the ether somewhere. Oh, here. This is giving me an error. Let's do that so I don't break things. So if you do return, it's going to come back. And what you actually do when you're writing code a lot of times is you're going to have return statements. These functions are going to be sending information and data for one function to another function. And you're going to use print statements to send things out as a developer to kind of understand where things are going and what's happening there, give yourself information and that sort of thing. So that's kind of the big difference. Is a return statement is the standard way for a function to give back information, but it won't show you anything. And print is a way for you to see things.
Internal versus external.
Basically, yeah, you can think of it that way.
So do we need to give a
Question.
maximum?
Yeah, so let's run this thing. So we could do our, container filler, and then we'll give it, I don't know, 5, like we said in the example. So we save that, and I can just take this stuff out because we don't need it anymore. You can leave it if you like, and then we'll run our command. And you see each time it runs through and it says, okay, so your container has this many items until it's full, and then it finishes. So we could put another statement at the end on the outside of this while loop to show that we know that it finished and give us some sort of information, and just say like, the container is full. And since that's outside of what's called the scope of this while loop, it'll only run after everything is already completed. Right. So just real quick, we show how that goes. And then similarly, it ran the 5 times and then it says the container is full. So I did want to highlight that there is, keeping in mind the sequential control structure, the placement of this increment is really important. So we could cause ourselves an off by 1 error in our logic here if we move it after the print statement, because now it's going to print out when there's nothing in it, and then it adds 1, and then it says I'm printing out 1, and then it adds the second, and so it'll say it's full at 4 when it's actually full at 5. So keeping in mind where you place the changes that you have to these while loops is important.
So you were saying that like if we didn't do either, what was it, the count plus equal 1, or is it the setting the maximum that would cause it to just keep running and break?
Yeah, so let's break it now. So there are several ways we could break it, right? So one of the ways we could do it is if there's never a condition, there's never a way for this condition to not be true. So if this condition is always true and it doesn't change, this will go on for an endless loop, and it should at some point tell us that's not working anymore. So I'm going to comment this code out. I'm just going to put a hashtag in front of it so the computer will skip this line, and that's basically not going to change this condition, right? So that should cause an endless loop for us. So I'm going to save that. And this time when I run it, it's going to do this a bunch of times. Then it's going to say your console is printing so much that it's interfering. It's out of the way with other users, so it has been closed. So basically Python Anywhere has a guardrail in there that says you're using up way too much. You have now been stopped from using that much. So I'm going to have to go back to my consoles and open a new console because I don't have one anymore. So it forced me to close
earlier today.
Nice. This is one of the beauties of doing it in Python anywhere, because you're not going to crash your home computer to do that, and it's not going to destroy anything. So let's do another way of reaching an endpoint of this. I think this will do something different. So let's do some gigantic number in here and see if it gives us a different result. This should equally stop us at some point and say, okay, that's too much. But I think it gives us a different error. Oh, I'm going to do my Python 3 main.py. Nope, still says the same thing. So basically what happens is this is just going to go. It's just going to go, and then it'll reach a certain point and it'll stop you. And again, that'll be like the maximum ability of your computer is kind of what is going to stop you at some point. So while loops are a little dangerous, you got to make sure to use reasonable sized inputs. Make sure that your condition changes, or else you're going to be stuck in that loop going on forever. Any questions?
So this could cause like legitimate damage to the system.
I don't think so. I don't think it's going to cause any permanent damage. This is going to crash it and you'll have to restart.
Oh, okay.
So it's more annoying than anything else. But I don't actually know. I may be causing some horrible damage to my computer and be unaware of it, but I'm not aware of any physical or like long lasting damage that'll be caused by it.
You want to find out?
Yeah. I'll find out later. Yeah. You find out and let me know. All right. So those are the basics of parts and pieces that we need to build logic to start solving problems. I think Josh, we're gonna put off that your specific one. It's a little bit later. Let's go through classes, and then if we got time when we get to logically solving problems, that might be something we can demonstrate towards the end of class. But any questions about those, about loops, while or for loops, basic if, elif, and else statements? All right. Then let's switch gears a little bit and let's talk about one of the coolest things in Python, classes. These things are awesome. But again, it's somewhat of a slippery concept on when you might use them. So at first you may not be writing a lot of classes, but you absolutely can't talk about Python without talking about them. This is not a Python course, but we will be using them. It's inescapable. It's going to be the way that we represent our databases when we write our application is going to be in a Python class. So we have to be familiar with them to a certain extent, but don't feel terrible if, again, this is one of the slippery things where you're like, I'm not really getting why you'd use this and where you'd use them, but ask tons of questions and let's go through them now. To do this, though, I'm going to move to a different file, and I'm also going to demonstrate the thing I've been promising about showing how this will allow us to link files together and call it from one place. So let's do that I'm just going to go up and do this in the GUI. And for now, I'm going to exit out of my main file. That's fine. Leave it where it is. I'm going to go back to the same directory. So I'm in my home / and then my username directory alongside my main.py file. And I'm just going to make a new file called classes.py. So classes.py. And that's going to take me to this blank thing. So I'm going to go down a couple of lines and I'm going to put in our app entry point because we're going to call this directly a few times for demonstration. And at the end, I'll tie it all together through the main one. But I want to talk about classes without being distracted by that. So for muscle memory, let's go through that. If double underscore name double underscore is equal to the string double underscore main. And then another thing that's really handy in Python, I'm going to demonstrate the word pass. It's a reserved word that you could put into any function or any block of code or something like that, that when you don't have a part to put there yet, and it won't break when it reads. So when I save, there'll be no error warnings or anything like that, and this will run. It just won't give us anything. It'll just move on without breaking. Whereas if you left this as a blank line, it would say, what's going on? There's a syntax error. Where are you at? There's nothing here, So pass, helpful. Let's fill that in for now. And let's talk about classes. So classes. Before we go into how to write them, what they are conceptually is something like a template. So if you think about, we're going to use cars as an example. If you think about a car, right? And if I say that word car, you're probably thinking about something that's maybe, probably got 4 wheels. Most likely it's a sedan of some sort with 4 tires. It's probably not like a tricycle kind of thing or some weird thing like that, right? You have this image of a generic looking car, but you have ridden in, probably own, and have driven concrete specific cars, right? So what we can do in Python, and the way that relates, is a class is a description of what a car is with all of its attributes and the things that it can do. So, cars have like a year, a make, a model. It'll have a color and mileage and all those things that could be about it. And then it could do certain things, like it can start and it can drive and it can turn, the doors can open and all those different things it can do. Now, each car that exists is going to have specific things of that, right? So each car has a year, but each car, actual car, specific instance of that car has a specific year. This is what Python classes do. We define the template, and then we can, in our program, create instances, as they're called, of that template. That make sense, everybody, kind of conceptually? All right, let's play around with them. And as questions come up, let's go. So to start a class, we use the reserved word class, which is nice and easy to remember, all lowercase, and then a space. Now, classes, by convention, we can call them anything, like always, like when we define our own classes, just like we did with functions. The names are fairly arbitrary, and Python doesn't really care. By convention, we capitalize them, though. So we're going to do capital car, C-A-R, and then that does not require parentheses. You can use them. We will see parentheses later, but again, as most basic version like this, you don't need them. Just a colon after the name of your class is totally acceptable. All right, so from there, we can define what are called attributes of the class. And these are going to look syntactically in the way we write them exactly like variable names. So let's give this car template the kinds of things that we're going to use. And for this example, we're going to give it a make, and we're just going to set that to a blank string. This is a really common way to do it when we don't want to give it a particular value to start with by default. We want to give it to something that's just a generic placeholder. It's called an empty string, so it's just the quotation marks. And we'll do that for model, set it to an empty string.
Could you also do this in a list format?
That's a really good question. I don't think, no, you couldn't. I think that would probably mess things up, but you should give it a try, see what happens. This is, because that would be, so this right here is not as loose as like when we were writing in the Python 3 or just like writing in a file somewhere down here outside of a code block. Once we're inside the scope of this class, which we are, we're indented in here, it's going to expect some specific things. Like it's going to expect attributes, which are these. that are written like this. And if you have just a list in there, it's going to be like, what is this? What is this doing here? It's not going to treat it like just a Python list that's out by itself. So I'm fairly certain that'll break, but I've never tried. Maybe give it a shot, see how it goes. I was going to say that there's another option for this. You could use that built-in placeholder string that's built in, but that's more keystrokes than an empty string, and it's functionally the same thing. So there's really no need to do that. And this, the year, we could set that as 0 so that we know to expect an integer. But this is so loose that we could set it as a string and then pass it integers later, and that's okay. It wouldn't really break anything. That would be fine. But this right here is an exceptionally basic but fully formed class. It has 3 attributes, a make, a model, and a year. So what we can do with that is now in here, we can what's called instantiate our class. We can make a particular car, right? So if I wanted to do my car, so I'm going to do a variable down here in the main thing, do my underscore car, and I'm going to set it to an instance of that class. And the way I do that is the name of the class, so capital C-A-R, and then open and close parentheses. And so this is going to create and save in my variable called my car. It's going to create a version of this car from this template. And now I can do things with it. I can set its make, its model, and its year. So I can tell it which parts to have, right? Or what those attribute values are. And to do that,
Here
it's
in the-
interact. What's that?
Here in the code or when we run the program in Python?
Good question. So I'll show you. We're going to go through hard coding it right now. And then we're going to step through a process called refactoring, which we're going to go through a bunch of times in this course, where we rewrite our code and the function goes basically the same way. But there would be ways that we could do it interactively if we wanted to, right? And I'll show you more ways to do that. Right now, we're going to hard code it, though. That's a really good question. So we're going to go line by line, adding each one that we're going to do. So we say my car, and the way you interact with classes generally is through dot notation, what's called. So we do the name of the instance of our class, so my underscore car dot, and then just the name of the attribute that we want to set. So we want to say the make is, we'll say it's a Chevy, we're gonna go with like my first car on this one. So underscore car dot model, and you're welcome to use whatever you like. I had a Chevy Celebrity. It was awesome. It was my car. It actually wasn't. It was a terrible car, but it was fun, and it was 1987. So now I have set these things, and to verify that I did, we could put in a quick print statement in here with a formatted string and some basic information about it. I'm actually, yeah, let's do the formatted string. Say I am a, and then we'll say year, make, and model in kind of the way that we normally would say it, right? Like, so this is, imagine, since we can't actually see these things, is something you could just look at the car and know there's a Chevy Celebrity 1987 if you're that into it. But this is like the car announcing its details, right? Saying its details to you. So we say my underscore car dot year inside the curly brackets, and that's going to put that inside of the string. So we reference the attributes in the same way that we set them with just the dot notation. So we'll say year, and then we'll do my underscore car dot make, and then the model, right? So my underscore car dot model. All right. So then when we save that, what's this telling me? Oh, anybody see my syntax error here? Before I fix it, let's see what I missed. In this line?
Parentheses.
The F in there?
The closing parentheses. I missed my closing parentheses. So the F, yeah, the F is to signal that it's a formatted string. So that lowercase f is helping us out so that we can do this little piece of interpolation here. All right, so when we save this, and again, we're going to run this directly by calling it the classes.py, or I could just run it right in here for demonstration. We just do that. Run this file. If you have one console that's available, just hit run, and you can see at the bottom. And if not, then you can do the Python 3 classes.py from the Bash console. But the idea here is it just prints out this says, okay, I am a 1987 Chevy Celebrity. So we instantiated a class here. We set our class definition up here. We instantiated a version of it and saved it in my car, and then we set those attributes that we gave it here and had it print out. So this is, in, again, very, very basic way, how classes work. We can we define them, and then we can use them in this way. And we could make any number of cars in this exact same way. So I can make your car, his car, anybody's car, doing the same thing and just instantiating one and then setting each of these attributes. Any general questions about that?
Could you change it to, excuse me, could you change it in any way where like those inputs could be like user input on the console itself?
Yes, yes. And I love that you're just like going straight to user input all the time. But we will get there. Let's get through the refactoring of this, and because there is a way to set these things all in one line and pass them as attributes. And let's go through that, and then I can show you user input. It's a built-in function that's pretty cool in Python that we could use to do how those set. But yes, there is absolutely a way to do that, and it'll make this a lot cleaner. And it'll kind of get to Daniel's question earlier too on, we don't have to do this all explicitly like this on each line. Good question. Any other general questions about this syntax or kind of what's happening here, how we got to this point?
Not on that, but I tried running it, and it said I reached my console. The console's reached its limit.
Yeah, if that happens to you, yeah. And
I deleted the main.py console, and then I tried running it again. Now it's saying name main is not defined.
So
I don't know what I did, man.
This make sure you have both of your double underscores in there. It sounds like you may have just used and both before and after.
Yes.
Okay, and is it in the quotation marks?
Yes.
It is. So it sounds like it was referencing a variable name. Like that error sounds like a variable name that was referenced, and this shouldn't be a reference. It's like this shouldn't be a variable name that you're referencing.
It's line 8. Oh, I put if main equals main. Let me change that to name.
Oh, you put main here instead of name?
Yeah.
Yeah. Again, real easy to do. Those are just like the same phonetic set. All right.
There we go.
Cool. Working?
Yes.
Nice.
Thank you.
All right. Excellent. All right. So the other thing, so these look like variables, but when they're inside of a class, they're called attributes. So these are class attributes. This is one of the ways of setting them. We'll leave those for now. The other thing is really important to know about classes because it's a grouping of data and functionality. We can also have what's called methods. And methods are just, they look like functions. They're written the same way as functions, just like variables inside of classes. They're called something else, right? So when we write a function inside of a class, it's called a class method. So we're going to do that example here by refactoring our code. This is the first time we're going to refactor, which means we're going to rewrite this code so that the function is basically the same. It's still going to print out this same statement, but the code that we write is going to be structured differently, and that'll make it either easier for humans to read or run more efficiently for the computer. In this case, it'll be probably easier for humans to read and a better way to do it. So we're going to move this print statement inside of the class and make it a method of the class so that it's something that each car can do as its own method instead of having to write this full thing every single time. So just underneath our attribute list, give ourselves some space on the same indentation. We're going to define, so DEF like we have before, but again, we're already one indentation in because we're inside the car class. We're going to define a method, we'll call it display underscore details. This is going to imagine a vehicle that you can look at, but we can't actually look at it, so it's going to tell us what it is with its year, make, and model in that order, right, is the general thing. It's going to be this print statement, basically. So one major difference from functions and methods is that, again, since methods are inside of classes, there is always one input into the method, and it's always self. You got to start with self. If you forget to put self in here, it's going to break. So remember to put self first. You could put other ones. We'll put some other things that could be passed into our methods here soon, but it has to start with self because it's going to refer to the instance of the class when we do this. All right, so for the substance of this, we're just going to move. I'm just going to take this whole thing and cut it out and just paste it in this block. I had that little error in there because I saved it before I actually finished my code. So now we have our print statement. I just moved it up into the indented block inside of our method. So it's 2 tabs over or 8 spaces. And now we have to do some other changes to this. Before I do, does anybody see what else needs to be changed? Can anybody tell me what else we need to change?
Well, there's no command at the end to run it or whatever. Right?
Okay. Yeah, we definitely need to call this method down here. That's one thing. Yep. What else? What else could be? Because that comes next. That's definitely one thing that's missing. What else might need to change about this statement particularly now that we moved it up into the method and it's not down here?
Oh, it's not going to have any information. You're going to need to do a loop so that it can get the data, right?
I think you're close.
You
All
have
that
to
through
show-
what
yeah.
data?
Because you define the my car, make, model, and year down below it. Up above, it doesn't have anything to refer to.
Exactly. So what do we have to change this to?
If has to go up above.
No, the if is in a good place. We have to change this to something though. What do we change it to? Sorry, Greg, I put you on mute, man. We got some background noise. You take yourself off if you got the answer though.
Would it just be the class?
No. Close to the class. Yes, it's the class. So Josh, right? Yes, it's the class. But how do we reference the class that we're in?
Oh, the
Car.
car.
Just car.
Capital C.
No, almost. Self. The word self is talking about itself. So we can reference inside of our class, and we're going to do this a bunch of times. So inside of our own class, we reference itself. This word self is exceptionally helpful in classes.
Self is reference to the name of the class.
It's reference to an actual
talking about itself.
Yeah, it's actual instance of the class. So like self is going to be the actual concrete car once it's made. That's the self.
I see.
So once it's instantiated, it has a self to reference. All right, so this is a method. And now we have our method. And like Greg pointed out, now we just got to call it. So underneath all of our setting of our attributes, we're going to leave that how it is because we don't have to make any changes there. Now to call our method, so down I'm on my row 14. I'm underneath the attribute sets. I'm going to use the same instance, the my underscore car, and then dot, and then just the name of our method. So display details, and then open and close parentheses. And this is going to give us, just like a function, this is how method calls look. So I want to save this. I'm just going to run it here. And it should give me the exact same output because, again, we changed the way it was written, but the functionality hasn't changed. So we've refactored our code. That making sense? Any questions about methods, attributes?
So does the method, is that just like bookmarking it until it can get the data later on down the code?
Basically, so this is really what we've done before, where it's defining this and just having it set up. So then the computer's going to read through this like it did before, sequential control structure, starting at the top and say, okay, cool, I got a class. This class has these attributes and it has this method. Awesome. And then once we instantiate it down here on row 10, and we create an instance of the class called instantiation, then we can use those things and interact with them. Right. So this is just defining what all those things are going to be and is ready to go. And then down here, when we actually use it, and it's referencing it. Does that answer your question?
Kind of, yeah.
Okay. Is there still something not clear, or could I make it worse?
No.
Okay.
I think
Not
we should
yet.
move on before the
All
power
right.
goes out.
Okay, cool. All right. So from here, let's do another kind of couple sets of refactoring. I'm going to show a really common method that you'll run into all over the place. And I kind of want to just show the things that are in there and explain them because it's something that didn't make a ton of sense to me. And then once I understood it, it was really helpful to know. So let's go through that real quick. This is a way that'll get us to, Josh, kind of what you were saying, a way to take user input and set our attributes when we instantiate our class. And the way we do that is with a method that's a built-in method. So we're going to write another method up here above the display details. Again, because it's going to be one of the first methods that we expect to use. So we use def like we have before, def. And then another couple double underscores. So this is kind of a reserved thing. So double underscore, init, short for initialize, and then two more underscores. This init thing is all over computer stuff. If you've done any other languages, you've probably run into this someplace. But again, it's short for initialize. The double underscores are showing that it's a reserved thing to make sure that nobody else is using it. And then like any other method, we have to make sure that we pass self into our init method. Now what we can do is move these attribute calls. I'm just going to cut these out. And I'm going to paste them down inside of our init function. Right? And make sure that they're properly indented. So 2 tabs or 8 spaces over. Just going to make model in year. And once again, what else needs to be done with these to make sure that we're actually setting them right?
Pass them through self.
Yes, we have to use self. So we have to use self.make, self.model, and self, properly spelled, self.year. Okay. So now we've refactored that a little bit, but that's still not very interesting. We have to manually set these same things down here. So we need to change that part to where it's not quite as manual. We can do it a little bit more automatically. Now, there are a number of ways to accomplish this. We'll go through 3 of them. I think there may be 3. We could explicitly tell this thing to expect a make, a model, and a year by just passing them these variable names, which again are arbitrary. We could put this as whatever we wanted to, but for ease of humans to read, and then just set the make, the model, and the year like this. So we could do that and have it set up. A much more common way to do it, and a much more kind of like Pythonic, as they like to say, way of doing it, is using a couple of built-in things. So we're not gonna do it this way. This is a viable way to do it, but I'm not gonna step all the way through demonstrating that it works. Just be aware that you could explicitly set other inputs in this way and then set the values to attributes in the way that I have it shown right here. What we're going to use, when we take those out, is something called an arguments list. So it starts with an asterisk. And then for demonstration, I think this can also be arbitrarily named something, but args is the convention, ARGS, and that stands for a list. Sorry, I'll keep that at this. We'll do another one later. And so what that's going to do for us is we can now reference this list, ARGS, by the index of the thing that's in there, right? So we just do args 1. What am I doing with these numbers? And then args 2. Since we're going to have 3 things in our list, it's going to be 0, 1, and 2. And with this asterisk, that means it could take 0 or more of these things. So this will also help it, as opposed to explicitly writing out each thing to expect. If one of them is missing or something like that, it won't break in that first part. It may break down here, but it won't break on those other parts. So this can take it 1 or more of these arguments. So it's more flexible, and there's less code to write. You don't have to explicitly write each argument that's going to go in. So what we need to do then is pass our arguments in the order that we want them to be pulled out, right? So we want our make, model, and year to be passed into our instance in that way. So all we're going to do is we're going to take our make value, just the string, and we'll put that into our parentheses. Go ahead and delete this, so we don't need that anymore. And do the same thing with our other 2 values separated by commas. All right, so we got our make, Chevy, we got our model. Then we'll put in our year, and I'll take out those other 2 things. And now when we instantiate our class, we can pass those values directly to it. And it should come out with what we want it to have, with far less code written all the way out. So I'm going to save this. I'm going to run it, and it comes out with the same output again. So we refactor our code again, and it did not change our output. But now we set it in a way where we could pass these things directly to it when we instantiate our class, and it'll grab those arguments out. So one downside to this is if we do it in a list, and then we pass the information in some other order, right? So let's say we're passing our model before our make here. The computer's not going to know, and it's just going to spit out the order in which we told it to, right? It's not going to know that this is actually supposed to line up with the model and that this is supposed to be the make. So it's going to reorder those things in the way that we don't want it to. So one way to get around this ordered part is to use an unordered thing of data. What data types did we talk about that are unordered?
Was it lists can go in any order?
No, lists are ordered. Dictionaries. Dictionaries are unordered, right? Yeah. So we're looking at lists right now. That's good. I'm glad you answered. This is a list. Args is a list. This other thing we're going to look at, we're going to refactor to use a dictionary, and it's unordered. So we're going to use another thing built in called keyword arguments. So this is going to take 2 asterisks and then KW ARGS, and that stands for keyword arguments. This ARGS stands for arguments. This KW ARGS stands for keyword arguments. And now to reference these, we look them up by keys. So I'm going to prepend all these args with KW. And then instead of the index, we have to look up the key that we want, right? And that's just going to match the name. We're going to make model, and we're going to have a year key. Now, down here, the change that we have to make is just have to set these keywords to these values. And we do that the same way we would set any variable name. So we say this is the model, right? And we just say is with the equal sign. And we say make is Chevy, and then year is 1987. So now it doesn't matter what order these are in down here in this row, in row 12. It makes no difference what order we put them in. When we run this, it will assign them properly according to their key, and it'll line things up with this the right way, or it should. So now you see down here, it switched back to a Chevy, 1987 Chevy Celebrity. So you're making model the way we want it to be expressed. So there's the 3 main ways, again, explicitly writing the names of the things you expect, or using either the arguments list or the keyword arguments dictionary. It's a real common way to pass all these things in directly.
Hey, quick question. When
Sure.
I've been following you and then resetting it and running it, and it says keyboard interrupt, but it gives me the expected output. Is that what?
Yeah, no, I think when you hit this run button, it's that's built into whatever script is behind this thing, that there's a keyboard interrupt in there. Usually a keyboard interrupt when you're in your own bash console is like control, you hit control C and it'll stop whatever process is running. And that's a keyboard interrupt normally. I'm not really sure what it's telling us in this one, but it does.
But
do that too.
it's working properly though, right?
Yeah, that's
Yeah,
part
okay.
of that's part of the thing that's actually working right. Yeah, that's not an error of any kind. So cool. Any other questions about this up to now?
I'm getting errors on line 7, and
Uh-oh.
it's also saying that quartz is not defined.
Ah, did you put 2 asterisks in front of it?
Yes.
Okay. Make sure you didn't capitalize it anywhere.
Did you put the quarks down on the make model year too?
Yes. I did quartz in one of them, but save that. Okay, that got rid of one of them.
Yeah. What'd you change?
I just had quartz in
Yeah.
one of them instead of quargs.
Ah, okay. Yeah, you gotta check your spelling on those things.
And I'm still getting an error. My car is not defined.
Ah, you still got my car in here somewhere? Above where it needs to be, I'm guessing. Is it in this statement? Did you not change one of these to self?
No, those are all self.
All right, man. All right, we're gonna keep rolling. If you can't figure it out by the end of class, I'll help you out one-on-one. All right.
Okie
So
dokie.
we're gonna keep moving through this. Hopefully it doesn't jam you up too bad. We're gonna go to this next little piece of again, like I've been promising so far, connecting this all together and running this through one main file. Right. So we go through the mechanics of that now. But real quick, again, any other questions about this construction and how we've done it up to now on this class's definition and how we did it? No? All right, cool.
I'm sorry.
So, yeah, what's up?
Sorry, I just had a quick question. I have to define KRs, quargs each additionally, right? Like I can't. It has to be defined separately after. I think I figured it out. I just
Okay.
make sure I have to define it because we put it in a string,
Mm-hmm.
like on line 5, define initiative self
Mm-hmm.
arg
Yep.
and then KRs, and then you have to write the series for self KRs and self model and KRs and self year KRs. Okay,
Mm-hmm.
no, I got it.
I got a quick question.
Sure.
Ours, you got 1 star. Key wars, you got 2 stars. Can you explain the stars?
That again is reserving things and setting it aside. I don't know why they used asterisks on that. I don't have a good answer for why they used stars.
It's like a reference. Is what it is, like a reference.
Yeah, it's kind of like saving these to make sure
Okay.
that they aren't, because this is not standard. Like you're not going to use asterisks for anything else in here that I'm aware of. It's just in this sense that I've really seen them. So,
Okay.
yeah, I'm not sure why they used asterisks exactly. There's one other place that we might talk about asterisks actually soon, but it's not related to those two. I'm not really sure why they use those.
Okay.
Don't have a good answer for you. But all right, so let's slide through another refactoring to move this functionality and tie it into our main.py file. Again, I really want to hammer home that all of this programming is just files and directories. So what we're going to start doing here is what's called importing the things that we make in one file into another file and run it through that main file, right? So to do that, I'm going to just cut these things out of the bottom that are underneath my block of the if main, and I'm just going to delete this entirely on line 11. So the only thing is left in my classes.py file is going to be the class definition of the car, nothing else. So there's no more name equaling main or any of that. We're going to move back up into our main.py file. So I've saved this. So it's just a car class definition, and I'm going to exit it. Don't need to come back to this for right now. Go back to the main.py. And underneath here, I'm just going to paste in those things that I cut from the other one where I define my car and I pass those bits of information. So when I save this, it's going to say, oh, I don't know what a car is. It's say undefined name car because it doesn't exist here in our, as you see, in this file. It doesn't exist anywhere. So what we're going to do is I'm going to go all the way to the top of the screen or at the top of the page. And this is typically where you put what we call import statements. And this is a huge part of Python. It's functionality called modularity. It's one of the cool things about it. We'll run into it in a couple of different ways. But what we're going to do is basically reference that other file and import all of our definitions from it or any definition we want from it so it can be used here. All right, so the way we structure an import statement kind of depends on what we're trying to import. When it's from our own files and our own directories, we have to give it a reference point with the word from. So we start with from, lowercase, and then we say the name of the file that we want to grab it from. So in our case, it's classes. We don't have to put the .py, don't have to put the extension, just the name of the file. It's assuming that it's a .py file because we're in Python. So just the word classes, then space, and then import. And then we tell it what we want to import. So you can, at this point, just use an asterisk and it'll import everything. That's import all. I highly discourage you from doing that. It's not a best practice, but it will work for most things. The reason you don't want to do it is because you might have a name conflict with other things that are out there. So you really want to be explicit on what you import. So we're going to write specifically the name of the thing that we want to import. So in our case, it's a car class. And if there were several things we wanted to import from there, we could separate them with commas and import them, but we'll get into a lot of that as we work with our web application. So this right here is going to give us the ability for our thing when we go to our console and say Python 3, go to this main.py file the way we have in the past. So Python 3 main.py. It's going to read this file. It's going to say, okay, from classes, import car. So it's going to go look in our directory where we are right here because we didn't tell it to look anywhere else, for a file called classes. When it finds that file, it's going to look for a thing called car, and it's going to read that thing. It's going to say, all right, cool, I got that thing. I know what that is. And then it's going to come back here and start reading this again and read all these definitions until we get down to our favorite app entry point. I'm going to save this, and it should get rid of that warning because now we do have our car definition. And when it gets to this app entry point, again, because we're going to call this main file directly, it will be the main file. So it will run this directly, but this is all referencing the car that's written in the other file. Right. So now when I run this should work exactly how it has before, but I'm going to reference the main.py, not the classes.py file. So let's go back to the console. We'll clear this up. I think if I can actually get into my console and the Zoom stuff is out of the way. Oh, this console's closed. That's why it's not working. So I'm going to go into a bash console that apparently I needed to open up again. So any bash console. And loading our bash interpreter. There we go. And I'm going to zoom in and make sure we're good here. I'm going to show you that we have our classes.py and our main.py in this directory that we're in. Those two files next to each other. I'm going to do Python 3 main.py. So not classes, not referencing that directly. And when I hit enter, I expect it to spit out this information, the details from the car instance that I made. So let's see if that works. And it does. So what we've done here with the app entry point in our main.py file is given ourselves the ability to reference and things that we define in other files, potentially in other directories. We could reference other directories if we wanted to. This happens to be in the same directory. But now what we can do is run this one file, and it can reference other definitions, other algorithms, and this can become a very complex application from there. Any questions about that? Is this making sense to everybody?
So could you just have like one master file full of like if or statements just pulling from different Python files?
Yes. And that's what when we build our web application, that is quite literally what Django is. It's a whole bunch of files in directories relying on this import statement and this functionality and modularity that Python has to do exactly that, to make something a little bit more complex and make a web application that serves traffic and does all that kind of stuff. But it's doing these things.
I'm going to dip in before power actually goes out. So
okay.
I'll
cool.
catch the rest on the video.
Excellent. Right on.
I got a question.
Yeah.
So I got the top part, the from classes import car.
Mm-hmm.
I'm trying to figure out how you got it to reference on the bottom line.
Okay. Down here?
Yeah. Did you type that in? I missed that.
Oh, yeah. No, I copied this I cut it from the other file. This is what we wrote in the classes file. So if
okay.
yeah, if you didn't cut it from there, or if it's still over there, you could cut it and bring it over. But this is the same stuff that I wrote on that side. So I just copied and pasted.
Gotcha.
But I can leave it here if you need to rewrite it.
Yeah, close that one. Well, I had to close it in order to open the bash.
Yeah, yeah. Fair enough. Any other questions about any of the things that we went over so far? So there's a lot more that classes can do and a lot more to learn about them, but this is really a good starting point to kind of familiarize you with them and understand the basic mechanics of how to create them, what they do. We will see them again when we do our web application. Again, like I mentioned, this is going to be the database, how we define our databases with classes. One other thing I wanted to go through, again, if there are other questions, please shout them out though, as you're going through. If you're still kind of catching up, we're still making sure things work. If you have questions, shout them out. But there are a couple other things I wanted to go through on kind of like training tools and where to go from here and how to practice the things that we've learned as far as the syntax with these different loops, the lists, the dictionaries, strings, integers, and all those sorts of things that we talked about as basic pieces. But before we touch on those things and wrap up, are there any questions about classes or about how we're running this as an application through the app entry point?
I missed how you copied the code and then where did you paste it in?
So this is just in the main.py underneath our app entry point part. So the if double underscore name double underscore is equal to the string double underscore main. And I put it inside of this, right? So this is just, we could instantiate another car in any way down in here. All right.
And then when you typed it into bash, you typed in Python main classes. So you have to reference both?
No, you don't. Sorry, that's just to have them listed. You just have to reference main.py. That's it. So
Mine
this
says
is
car.
our, what's that?
Oh, sorry. I'm sorry. Go ahead.
No, I was just saying though, once you have this app entry point made, that this is just how you access it. Is just this call right here, the Python 3 main.py.
I'm still getting
all I'm getting when I do that is hello world.
Uh-oh. So you must be in this thing still calling your hello world thing somewhere and not calling these.
I'm still getting the container has 5 items.
Oh, okay. So you're still calling your container filler in here. Make sure you save before you run it. If you didn't save here in your file too, if you made changes and didn't save it, that's a real common thing to do too.
It says main car is not defined.
Oh, this right here is not defined? Okay. So check your import
Yeah.
statement. Do you have this up at the top where it says from classes import car?
Oh, I had that in the classes.py.
Yeah, no, it's gotta be your main.py, right? You gotta import it from your classes file into here, or else it's not gonna know that it's there.
Let's save it.
All right.
Oh, what? Now it's got more errors.
Uh-oh, more errors. All right, so I'm going to crack on just a few more things. And if you're still running problems, again, I can hang out with anybody at the end of class, and we can go through your specific issue. But I wanted the last few minutes to go over a few things that we have in the coding resources specifically, and I'll highlight those as really good tools for practicing this stuff. And then I'm going to send out like a list of practice problems for kind of working through and making algorithms as well. These are like great tools for it. So before I show those things, I want to highlight the in the free resources, the free code camp is the very top, is one of the best, one of my favorites. And as you're trying to understand Python specifically, they have this old legacy course, is Python for Everybody, that is a set of videos that are short. And there's this guy who's like from Michigan, I want to say, that's explained, some professor, and he does a really good job explaining these things. And then also the scientific computing with Python certification is practice with all the things that we talked about and way more in depth about Python and using it specifically, broken down into very short lessons, very small increments that you could do in just a few minutes here and there. So I think those are really, really great things that I encourage you to play with and use. But we're going to go down to where it says practice and interview prep. There are two sites that we listed here that are really good for practicing writing algorithms and solving problems with them. And both of these have been recommended to me by people who are, professional developers, full stack developers, backend developers. And whenever they're getting ready for interviews, folks that are coming out of college with CS degrees and stuff like that, LeetCode in particular is one that's used for getting ready for interviews. They have lists of questions that are actually asked by specific companies like Google and Facebook and stuff like that are in there. Code Wars is the same sort of thing, but it's a little more beginner friendly in my opinion. So I recommend you start with that, but we're going to go through these and kind of have a look at them, show you what they are and what they're about. So this is an example of what Code Wars looks like. And when you go to Code Wars, there will be places to choose a number of problems like this, and it'll have a name. Like if you go up here in the upper left where it says extract the domain name from a URL, that's the name of this problem that you're trying to solve. And so over here on the instruction side, it'll say write a function that when given a URL string parses out just the domain name and it returns that string. It gives you some examples of inputs and expected outputs. And then over here on the right, here's our pass thing and a function that's built for us already that says domain name, and you're supposed to write your code in here and solve this problem, right? And down at the bottom of all of these things, there will be tests that are built in. So we didn't talk a lot about testing and how that works, but this is a great place, again, to kind of mess around with some actual tests. We're not going to break apart each bit of this. It's worth reading, but you can see some things that are now a little more familiar. You got import statements. There's some definitions of some functions and whatnot. But I want to call your attention to this right here where it says assert equals, and then it says domain name, and then there are these two strings, right? So the first one that's in here is the given value in this test, and the second one is the expected value. So you can write your own test in here by copying and pasting this test.assert equals and then changing this to different things, and it'll run through that for you. That's what this is doing. So it's good to kind of know what it's doing. It's good to read it. When you come to these, though, when you write your solution, there are two buttons down at the bottom, one test and one is attempt. Test will run these tests here. Attempt sometimes will run more things than are in your test cases. So, you have to kind of plan for edge cases and things like that. But I encourage you to run test and see how it goes. And you look over here on the left side to say the output. It'll show you what you failed. It'll show you the actual result, the expected result, and then you can go from there, right? So you go and fix your code to try to get the solution that you want. Not going to work through solving one. I mean, we could, if we wanted to, we kind of go through one together, but I want to show that this, once you've solved one, you can look at other people's solutions. And that's what makes this such a cool training tool is, you'll bang your head against the wall for a little while, you get one figured out, and you're like, great. And then you go in here and then somebody does it like a million times faster. If we look at my code, my solution to this, I solved it, but it's like 15 lines and it's not nearly this slick as what this guy did. So it's really valuable to solve the problem and come in and look at how many different ways, first of all, there are to solve them, but then also kind of pick up some tips and tricks on how folks do it and what they're doing and really read to understand their solutions. All right, so look at this guy did, some splitting of the string, which is a really good method to know. Got the last thing out of it using the -1 from a list. And as you can see, we did a whole bunch of operations just in one line. That's cool. And the next one, this guy uses a regular expression is what this is called. It's outside of Python. It's something that's used frequently in things. Not required, but possible. And as you scroll down, you can see there's all these different ways of doing it. This guy kind of looks like he might have been being a smartass and being really explicit, but either way, it works. So there's all these different solutions that work to solve this same problem. So there's no one solution. There's, sorted by maybe best practices or clever or newest or any of those sorts of things. And they can be upvoted and all that kind of stuff. So these are really, really, really great tools for practicing all the things that we talked about. And we put together a list of good beginner problems. Like you could filter through and find some of your own, but this set of 20, most of these are from Code Wars. Some of them are from LeetCode. It's a similar site. Both of them are free to sign up for. But I really encourage you to do these. This is gonna get you practicing using the things that we've gone over with the different loops and the lists. In particular, you can do a lot of lists. You can do a lot of things with strings and all the stuff that strings can do, chopping them up and comparing them to each other and doing all that kind of stuff. So I'm gonna send this out, and between now and next time, whenever you have time to do these things, do as many of these as you can. Some of them are really easy. Some of them are a little bit trickier, but all these are pretty good beginner levels. And if these are below your level as far as problem solving goes, these things have just endless amounts of problems that you can solve. And you just find other ones. And if you know other languages, you can practice other languages in these things. So really good resources that I encourage everybody to get on and use. Any questions about that stuff? No? All right, cool. So we got a couple of minutes left. We can wrap it up there if nobody has any other questions. Anybody that's stuck, welcome to hang out, and I can help get you unstuck. But before we totally wrap the class, does anybody have any questions about anything we covered up to now at all?
I think I'm just too far behind. I gotta go all the way back. And
okay. Daniel, do you have something?
I just want to say I fixed all the errors.
Oh, nice.
Yeah, all the errors went away.
Cool. Is it running the way you expect it to?
Yeah.
Nice. Nice. Right. All right. Anyone else? Okay. All right. Well, I appreciate everybody's attention and for showing up, and keep practicing with these things. Try to build up to this point that we're at now. I will send out, I'm not going to send, unless folks really want it, I can send out my copies of these files that we created tonight. But I don't have like a documentation for you to follow line by line like we have with the other things. But again, let me know if that's something you want. I will send out the recording like always. I'll send out this problem set for folks to practice on. And I do have solutions to these. So if you're stuck somewhere, let me know and I can flow you a solution. That's okay. It may not be the best solution, but it'll get you to the point you can see some of the best solutions. And again, we didn't have any slides for today, so that's about it. So it'll just be the recording in this list. And that's
what
it.
about what about those what sites you mentioned? Is that part of the list?
Yeah, absolutely. So that's on the free coding resources that we already sent out, and it is pinned in the Discord channel. This list of full resources, and the Code Wars and Leak Code are both on that. And you can get to both of those.
Was that an email you sent?
I did send an email with it.
Okay.
Yeah.
On
I received it on the 12th.
Yeah, it was the first day of class during the break, like right when we first started.
Oh, okay.
So I did have a quick question about your Discord server. It says it's down, so I'm not sure if I need to sign up for it.
Says it's down?
It says invite invalid.
Oh, maybe the invite's just expired. I can send you a new invitation. I think they're only good for a few days.
Okay.
So yeah, I can definitely send that, because I'll send these just for anybody that's not on Discord. I'll send them redundantly on Discord and email. It's basically the same information in both, but I'll send another link to the Discord in there for you, Nathan, cool, if you want to just follow the email.
Thank you.
Yeah, for sure. Anything else? All right, cool. And we were right at time. Next time, we're going to do probably our most computer science-y stuff of the course, and we're talking more about data structures and a little bit more about algorithms and the choices we make. We've talked a couple of times about refactoring and making decisions. We'll talk about how to decide what the best decision is based on the situation you're in. So it'll be a little less hands-on stuff, but it'll still be some valuable things. And then next week we'll roll into starting to actually use some of this to build something more substantial and build our start laying the framework for our actual web app. So no other questions. We'll be in touch soon with recording and problem list.
Thank you.
Yep. Thanks a lot, y'all.
Yep.
All right. Thank you, Jeff.
Yep. Have a good night.